right? So we derived this, and I remember I don't remember everything, but I do remember certain moments, and this one was kind of like at the buzzer. We only had like 5-10 minutes of class left last time, and I was like, by golly, we're getting this one in. So this was the derivation of the derivative formula, and you could see that it didn't, it didn't simplify itself very nicely, but it's actually in a pretty good position to get us where we need to go, which is a good thing, right? So, but it is a formula, and it's a nasty formula, and so you definitely want to hang on to this one. You want to put this one in your pocket and make sure that you always have it available, because I don't know that this is the kind of formula that you want to try to memorize. You can derive it, and that's usually what I do when I forget and I'm too lazy to look it up. You can derive it, but if you have it accessible, that's the key. All right, so the first example, write the equation of the tangent line to this function where theta is equal to pi over 3. Now, just a quick refresher, because we haven't really talked about this too much. The equation of a tangent line, very, very important. You will, on the first unit test, you will be asked to write the equation of a tangent line. It could be for a polar graph, it could be for a parametric, but it's going to be on there. And what people have incorrectly assumed is that I'm asking you just for the derivative equation. Because they say tangent line, that means derivative, equation of the derivative. Okay, so once I get the derivative, I'm done. No, it means that you have to have a final answer that's a linear equation. It's a linear equation. The preferred form, y equals m times x minus x sub 1 plus y sub 1. All right, that's the point slope form, or I call it the modified point slope form, where instead of having y minus y sub 1 on the left-hand side, I just brought it over to the right. It just makes more sense. It's ready to go into a calculator. It follows all the other standard forms, whether it's a quadratic or a trig function or something like that. So you have everything you need in one location. All right, so I need the slope. That's going to be dy dx. All right, I need an x value. Right, so it really is an x value. So we're going to be writing this equation in rectangular form. Right, so in order to come up with an x value, I need the relationship between x's and y's, and r's and thetas. So this goes back to right in the beginning of this portion of the unit, x is equal to r cosine theta. Y is equal to r sine theta. All right, so we need all that information. And once we have it, we're good, but the key ingredient here is going to be that derivative. All right, so we got what we need in terms of the dr d theta. That's ready to rock and roll. So now I got to start plugging and chugging. So I'm going to bring this guy over here. I'm just going to pop it right down just so I can have something to point to. I'll get rid of that. That's not a negative sign, it's just a stray mark that got carried over. So dy dx. All right. So we know what r is. R is equal to 1 plus the sine of theta. So I could replace all my r's with 1 plus sine theta. I can replace all my, or both of my dr d thetas with a cosine theta. And then I could do some algebra and clean it up. Or I can look at the fact that, wait, they told me what theta is. So why not just go after it that way? So instead of finding dy dx, why not find dy dx such that theta is equal to pi over 3? Right? And then off on the side here, what I could do is I could just figure out r of pi over 3. So 1 plus radical 3 over 2. Not really much else you can do with that one. Dr d theta, where theta is equal to pi over 3. So cosine of pi over 3 is 1/2. All right. I gotta plug in a lot of other stuff too. So why not just kind of detail it off on the side here? cosine of theta, for example? Well, theta is equal to pi over 3, so cosine of theta, cosine pi over 3, 1/2. Sine of theta, so that one was actually a repeat, but I figured I'd jot it down anyway. Sine of pi over 3, same deal here. Just kind of itemizing it, you know, just keeping it organized. And then I'm just looking around to see if I need anything else. Well, I know what the R is. So when it comes time to find R cosine theta, I'm just going to take my R and my cosine theta and multiply them together. So I don't think I need to do an extra step for that. All right. So, because it's going to happen right away anyway. So we're looking at, let me get a big old fraction bar here. All right. Oh, a little slanty. Oh, slanty the other way. All right. Man, it took me 3 minutes, but I got there. So 1 plus root 3 over 2. Cosine theta we know is 1/2. Plus sine theta, rad 3 over 2. Times 1/2. I'm going to trim down my fraction bar in a sec. I don't know what the bottom's going to shape out to be, so I'm going to leave it for a minute here. 1 plus rad 3 over 2. Negative sign, so negative rad 3 over 2. Cosine 1/2. dr d theta, also 1/2. So I got this extra schmutz here I don't need, so clean that up. And now I have my derivative. Now it's not in its most user-friendly form, so I'm gonna want to clean this up a smidge. So let's see where this takes me. Yo.
Sine pi over 3 is rad 3 over 2, right? You put it. I think you put it.
Sine pi over 3 is rad 3 over 2. Yeah. What I screwed up?
Yeah, on the first part, it says 1 plus rad 3 over 2 times. I mean.
Times 1/2.
Yeah, you're right.
I'm good. Okay.
Yeah.
Yeah, definitely keep an eye on me because you've seen it firsthand. I screw this stuff up all the time. So if you catch it, just say it. But this one I think might be okay. Good a time as any to do a quick double check. So that's what I was doing there. I'm going to multiply through with the 1/2. So I'm looking at 1/2 plus rad 3 over 4 plus another rad 3 over 4. And on the bottom, oh, why is he going sideways on me? Negative rad 3 over 2 minus, so the two rads are going to cancel each other out, so minus 3/4 plus 1/4. All right, so then when I put these two guys together, I'm going to get 2 radical 3 over 4, which is going to simplify down to radical 3 over 2. So 1/2 plus rad 3 over 2. Not much else we can do with just that part of it without talking about the bottom. Negative rad 3 over 4 plus 1/4 is going to be negative 1/2. So we're looking at negative rad 3 over 2 minus 1/2. For the sake of kind of not regretting this later on, I think it makes the most sense to clean it up by doubling top and bottom. Because all those denominators are 2, so we can wipe them all out. Because we got to plug this into the tangent line equation formula, so just for our own sanity, it kind of makes sense to take this time right now and clean it up. Negative rad 3 minus 1. Now I could factor out a negative 1. So that's great. These look like two exact opposite expressions. If I factor out a -1 on the bottom, I'm going to get two expressions that'll cancel out because it'll be radical 3 plus 1. So that's going to leave us with just a -1. So after all of that, it actually shockingly cleaned up rather nicely. So had I stopped, I mean, maybe I wouldn't have had to double the whole thing, but you know, it just felt like the right move. If you recognize that the two sets of fractions were opposite in the previous step, you could have just jumped right to the -1. But honestly, I didn't see it until after I doubled everything. So sometimes for me, that's a necessary step, not for everyone. All right. But now I have my dy dx. So I got the first part of my y equals linear equation. Believe it or not, I kind of have pretty much everything else too, because I need r cosine theta. Well, along the way, we figured that out. You know, we're just referencing the work that we've already done. This was equal to r cosine theta. All right. This part is going to be r sine theta. We just got to be mindful of the fact that it's got an extra negative involved. So we'll have to make sure that we don't carry that negative up. But this is going to set us up nicely for this. So for our tangent line, we've already done the heavy lifting. So y equals, so tangent line, -1, you obviously don't have to write the 1, x minus, so the product of those two things ended up being, and I'll just kind of highlight it here, it ended up being these two.
Is it negative sign or positive sign for y equals, for r times sine?
For y, it should be r sine theta. So that's what I was saying. We'll have to make sure that we don't bring that negative along for the ride in that blue box that I just created. Right, so 1/2 plus rad 3 over 4. And then plus, so the product of these two expressions just without that negative sign. So basically, these two guys, again, just without the negation of it. Right? So we'd be looking at rad 3 over 2 plus 3/4. Okay. So the handwriting got a little sloppy at the end, but that's the idea. We could clean it up a little bit more and see where this takes us. And again, just be mindful of the instructions on an assessment, because if it's not telling you to simplify, then you're potentially throwing away points, and you don't want to necessarily do that. You don't want to do that, period. I don't know why I threw the necessarily in there. So y equals, I'll leave the negative on the outside for a second, x minus 1/2 minus rad 3 over 4 plus rad 3 over 2 plus 3/4. Bring through the negative, so negative x plus 1/2 minus rad 3 over 4 plus rad 3 over 2 plus 3/4. And so there's not too much that we can do, but we can consolidate the rational parts and the irrational parts. So y is equal to -x. In terms of the rational parts, we got 1/2 plus 3/4, which is going to be 1 1/4, so 5/4. Right? So we can say plus 5/4. And then for the other piece,
should be plus rad 3 over 4, right?
plus radical 3 over 4. Thank you. Thank you. All right, so we're not, well, I guess I don't need to highlight the whole thing then. I can just take this guy and add it to this guy. So radical 3 over 4 plus 2 radical 3 over 4 would be 3 radical 3 over 4. Get a common denominator there. Right. So, you know, it took a little doing, and by a little, I mean a lot. But eventually we finally got to a linear equation that represents the slope of the line tangent to the curve at that particular location. All right. Now, if you're any way like me at all, which would be quite an achievement, you're going to want to know whether or not you just screwed this whole thing up, or if you have a pretty good handle on it. So that's where Desmos will come into play. Right? But maybe you just want to roll the dice, and also maybe you don't have a choice in the matter. Maybe it's the end of the assessment and you don't have time, so you just gotta hope for the best. So I'm going to type in the original function. We can eyeball where theta is equal to pi over 3, but we could also just evaluate the function too. So, all right, so we got a limacon here. So honestly, I don't know if it's gonna handle it. We'll see. Well, this is a good sign. Oops. All right. And so that does look tangent at pi over 3. So I'm feeling pretty good about this solution. All right. The one drawback, I guess, would be, and this happens fairly frequently for students, and it's unfortunate. We don't want to see this happen, but people thinking that they did a problem wrong because they failed to correctly type their functions into the calculator, whether it's a TI or a Desmos calculator. And because of that, they start second guessing all of their algebra. The algebra is perfectly fine. They didn't do anything wrong there. You just typed it in wrong. But because of that, they start erasing everything wholesale. So you just got to be careful. Just double, triple check how you type it in. You might have seen as I was typing it in, I realized before it was too late that only the 4 was going to be only under the radical 3 and not under the 3 itself. Now, because of the commutative property of multiplication, it might have worked out anyway, but I wasn't going to take that chance. All right. So definitely take your time and be careful. Otherwise, there is a price to be paid, and it comes out of your grade, and we don't like that. All right. So let me pause the recording.